Thanks for the very warm introduction. It's awesome to be speaking at Devnexus in person. I think that we've all been doing this behind the camera, doing stuff behind Zoom. And this was also my first experience, well, in a couple of years, to do last-minute edits to my presentation. So I think this is a presenter tradition, right? Your presentation's never done until you walk on stage. So if you read the program guide, it says something about hacking the OSS supply chain. I'll talk about security. I'll talk about all this stuff. But I thought about what really defines Devnexus as a conference. What makes Devnexus unique and special? Anyone? What? Be odd? Oh, everyone. Okay, so be all. Okay, good. But, all right, the t-shirts, right? Well, I'm not wearing the Devnexus, but the sci-fi. So it's all about the cool sci-fi references. So we're gonna explain security with sci-fi references. So let's see how I do. You're gonna rate me on this, right? Right, Glenn? Okay, cool. So let's start with some classic security examples. I think this is the one which kind of got the world super excited about the fact that we're all going to be hacked. And Equifax was exposed by a Struts security vulnerability. They had a huge breach which cost them $1.43 billion, affected about 143 million people in the US. And it wasn't their main system which got attacked. It was actually a side attack through a system which they forgot to upgrade from the zero-day Struts vulnerability. And then once they got in the internal network, the hackers migrated in and pulled and exfiltrated data about all of us. So now all of our records are stored in a vault somewhere in Russia. So this is kind of where security started, but it's moved on from here. And if you were watching the news in the past year about the SolarWinds hack and other supply chain security attacks, this is kind of the new method of attacking companies. What happened with SolarWinds was their CI/CD system got attacked. It happened to be, hopefully there's no JetBrains folks in the audience, but it has nothing to do with their product. It happened to be a TeamCity server which they hacked into. They then used this to modify the binary as before it was being signed, so that they were adding about 400 lines of malicious code into it, signing it as if it came from the SolarWinds company, and then shipping it to end users who now had a backdoor into their systems supplied by this. So again, this was a huge vulnerability. It hit a lot of government companies. It ended up instigating a White House security guidance on security, including SBOMs and other requirements for securing your supply chain. And this kicked off kind of a whirlwind of excitement, both in the developer community, but also with hackers and other folks who looked at this as a new angle of attack. And I think the most recent one, which everyone's talking about, is either Log4Shell or Spring4Shell, which is another exploit in the Java community where they found a zero-day exploit in the Log4j framework, specifically affecting only the Log4j core. So if you're just using the APIs, you're fine. But this basically affected almost all the systems on the planet. So I mean, if you're not using logging, you're doing something wrong in your development stack. And the fact that there was a vulnerability where you now could do side channel arbitrary code execution on any Java system on the planet was huge. Now, I think as a community, we reacted very quickly and we addressed the security exploit. But basically, it was a substitution issue where if you put stuff in and you were doing LDAP queries, then you could send back a class file, and the class file would get arbitrarily executed on the host. And that was an attack vector for you to get into systems which were using Log4j on an older version, and the current versions it's patched. And this is, from a community perspective, kind of the tip of the iceberg on security exploits. So we've been looking at the biggest security vulnerabilities, the ones which hit the news headlines, the ones which we all have to deal with. But there's a big, long tail of security exploits which are affecting us all. And I think one of the questions is, which of these systems do you guys trust? So is anybody downloading stuff or using JavaScript libraries off NPM? Okay, so you guys trust NPM? Anybody doing PyPy? Okay, a few folks. Ruby Gems? How about Maven Central? I hope. So like you're putting your trust in systems where you're getting code, you're getting binaries, you're getting open source libraries, and any of these could be potential attack vectors for a malicious hacker to get at your systems. So I think the question is, do you trust these systems, and are you willing to run these on your servers and in your deployments? And I think there's a great quote from Dan Lurink where he said, every time you pip install go get or maven fetch, you're doing the equivalent of picking up a thumb drive off the sidewalk and plugging it into your production server. So I think this is a huge security vulnerability. I was speaking at the Texas Cyber Summit last year, and great conference. They do different hacking contests, and they have a good culture there. And guess what they were excited about? They were excited about this. They were excited about all the new vulnerabilities and how much fun they would have hacking all our systems. So the hackers are getting just as excited about this as we are. OK, so like any good sci-fi reference, we have to start with a cult classic movie, The Matrix. And I'm going to explain some security vulnerabilities by using one of the classic characters. Like these are the Neo and Trinity and all the characters. But the real hero of The Matrix was the agent, Tom Anderson, right? He's the real hero.
What?
Huh? Oh, yeah, that's... All right, so apologies for Matrix 4. Has anyone seen it? Yeah, so you know what I'm talking about. So that's not the real. That's not the real. Well, I mean, that's apparently the new agent, but that's not the real agent. And I think I owe the audience an apology for putting this picture up, right? Yes. Okay. All right. So I brought a few forgiveness prizes. So we decided to go with the Matrix theme this year for the JFrog, the classic JFrog T-shirts. So like any good community presentation, if there wasn't an obligatory T-shirt throw, it would not be a good talk. So let's go. All right, you got one. The cameraman gets one. All right. And the real Tom Anderson will come out. OK. So I think when you look at Matrix, this is kind of an analogy to one of the potential security vulnerabilities into your system, which is that the agents disguised themselves as other people. And they were able to just flip around between different people in the Matrix. They had like complete surveillance of what was going on. And of course, they caused no end of trouble for Neo trying to get to the telephone booth or whatever the weird premise was. And this is exactly what the dependency confusion attack does on your systems. So basically, the dependency confusion attack is an example where the attacker is pretending to be one of your corporate libraries, a library that exists inside of inside your company. And just like the agent, they're masquerading as that library and trying to get into your system. Now, the way in which they got the data out of the system is they would use a DNS lookup back and use this as a system for pumping data out of your system to the attacker server. But I think the interesting part of the attack was really how they got into your system, which was exploiting the fact that NPM has no security on namespaces, and you can put up, and this will be a theme of some of the other attacks, you can just post a package and you can just name it whatever you want. And in particular, you can name it the same package names as internal corporate packages. So if you happen to know that, for example, Yelp has these internal packages, then you can use exactly the same names. You can put a higher version number, and that allows you to then override libraries inside of the attacker system. The internal developers, if they're just grabbing the latest version, they'd have no idea that they're pulling down a malicious package. So it's a very clever way of abusing it. Actually, there's a further layered kind of nuance on this as well, which is when you go and you request stuff from NPM, you also announce what packages you have. So it's not that you even need to have any internal knowledge about the package structure or the internal libraries within a company. The requests you're sending against NPM actually inform about what internal packages that you have. So basically, if you look at it, you're a developer, you're a CI/CD system, you're going through a vulnerable package manager, and you believe that you're getting your awesome corporate library, version 1.2, but then lo and behold, you're actually getting awesome corporate lib 6.6.6, which is the attacker's version, which they posted, and it appears to be a newer version because of the higher version number, and this is what will get pulled down when you use this. So this is bad stuff. And there's a few different ways which you can fix this. But one of the things which we've done with Artifactory, which is JFrog's package manager, is now by default, it won't go and resolve things against NPM. It'll resolve it against your internal repository first. And this prevents you from getting this attack by default, even if you're using a virtual repository, which mixes the two together. So I think this is something to pay attention to, particularly if you're on an old version of a package manager or a package repository, or you're using a product which isn't hardened against dependency confusion attacks. And this also made the author, Alex, quite a lot of money. So he did bug bounties against all of the big tech giants, I think Apple and Microsoft and a whole bunch of other companies, collected $130,000 in bug bounties by reporting this, and also showcased how you could exfiltrate the data and make a successful attack against this. So not only is it a big risk, but it's also lucrative for hackers to find these sort of opportunities. Okay, so this is one example of a potential attack, and I think for the next one, I'm gonna pull in another sci-fi reference. So I think a good analogy for this next attack is like a smuggler who's smuggling in packages or putting bad binaries, kind of like the Millennium Falcon.
What?
Oh. So this actually this would be great for a T-shirt. Somebody should make a T-shirt out of this.
I'll let Vincent know.
Yeah. So Vincent has some awesome T-shirts mixing the Millennium Falcon and the USS Enterprise. Anyone know exactly which number this ship is? NCC at 1701. Okay, give that man a prize. Can you get a sticker, Glenn?
I'll find one for you.
Okay, we're gonna get you a sticker.
That
is very impressive, and you haven't been insulted enough to run out the audience yet. So thank you. Okay, so of course I'm talking about the Millennium Falcon, and so just I think one of the things we put a lot of trust in is that the packages which we're downloading from central repositories, that they come from reputable people, that they're uploaded from people who built on a clean system that was properly security scanned. But would you trust your cargo coming from a guy like this? So Han Solo in the audience, stand up, come on. Okay, so if you're not following Han Solo on Twitter, that's Garrett, and I would trust you, Garrett. So if Garrett uploaded a package, I would totally download it, but you shouldn't. And actually, as an example, PyPy, which is one of the most widely used package repositories, it's really easy to upload whatever you'd like. You can just upload packages to it, and there's very few constraints on it. So our security research team, they're a new team which we bought from an acquisition. They just do zero-day vulnerabilities. They look for different examples where they can hack into systems which are open source. They do a lot of analysis of binaries, and rather than just looking at the source code, they'll actually inspect the binaries and look for exploits of things where they can reverse engineer it. One of the guys on the team, Svetter, so this, do you trust Svetter, right? Looks like a nice guy. He plays ping pong. He's like a really cool developer. And he uploaded Svetter 0.8, which you can actually, this is in PyPy, you can download it and give it a try, and it opens his website, right? That's legit. Now, if Svetter can post a completely useless library into PyPy, so can you, so can the attackers. And this makes it a very easy attack vector for getting things which are malicious into developers' hands. And actually, it's worse than this, because when you download packages from, or when you have a dependency on a package from PyPy, you don't even have to run the library, because there's a packaging script which is executed when it first gets installed. So just by the fact that you've installed a package or you've used a dependency on a package, your system is compromised without even running the package itself. So we ran through and we looked for malicious packages, went through all of PyPy, got 6,000 hits initially on potentially malicious packages, and found a couple notable ones. So Noblesse optimizes your PC for Python. Actually, it steals credit cards and passwords and exfiltrates through Discord. Pythagora, making Pythagorean theorem easy. And this does arbitrary code execution. Together, these got about 30,000 downloads combined. And you can see that they obfuscate the code. So it's hard for you to, as an individual, to identify what's going on. But when we actually look at what they're doing, typically what these systems are trying to do on your developer machine is they're either trying to get access to, for example, some of them will use, if you have like, was that Discord, the premium Discord service? That's a common attack vector where they try to steal tokens for that. Sometimes they'll try to get information out of your browser as well. So they'll, basically the browser security system for storing your passwords is 100% secure from websites and web pages attacking it, but entirely vulnerable from any sort of desktop or anything which has access to the command line. So you can just rip all of your credit cards, addresses, everything else straight out of your browser store as well. And it's all stored basically unencrypted. Encrypted with user credentials inside of a SQLite database. So very easy to attack and get all this information out. And here's the actual code once you decompile it from one of the systems, which I was talking about, where it basically goes through, decrypts, and then pulls information out. OK, now let's go to the next attack. And again, we need a good sci-fi reference. So we're going to go way back. Anyone remember War Games? All right. So this is kind of like a classic, one of the earliest movies which talked about kind of hackers and thermonuclear war, which is particularly relevant given what's happening in the Ukraine and Russia. And let's launch an attack. Let's play a game. OK, so who? Just shout out. Somebody give me the name of a city in Russia. OK, I heard St. Petersburg. Moscow. OK, let's do this. OK, so let's start with Moscow.
What?
Oh. Anyone here from Idaho? I'm sorry. So Moscow, Idaho is now off the map.
No, that's Moscow. But...
Yeah. OK. Sorry about that. OK, we got this. St. Petersburg, right? Easy. Oh.
Dang it.
OK, so what happened here? What happened? So we told the machine to bomb the city, and it did what we wanted to, and now we've blown up a few states in the U.S. But it was incomplete namespacing, right? We didn't specify the country and then the city. We just went, maybe the planet too. We might be shooting alien cities too if we're not careful. So this is an attack vector again for NPM, and I'll get into that just a sec. But I wanted to give a quick nod since we were talking about thermonuclear war and Russia and all this stuff. Now first of all, I think that this is not a nick against anybody, the people of Russia or what's happening there. But the situation in Ukraine has been really tragic with what's happened to them getting attacked. And one of the things which we did at JFrog is we actually sent a delegation of folks to the Poland-Ukraine border. And they were doing relief together with a company called One Heart, and actually like giving out supplies, trying to help out refugees. Of course, JFrog t-shirts, because why not? You need to be warm. And I think that this is a great way, as a company, we were able to show that we care about the situation and we're trying to do the right thing. Plushies as well. And this was the first team which went out, which included our CEO. So the fact that we're sending our CEO to a war zone, he got COVID from this as well. Actually, most of the crew got COVID coming back from this. So I think it shows that as a company, we care about doing the right thing. And it's a horrible situation, but we should all do our part to try to make things better. OK, so now getting back to thermonuclear war and libraries and attacks. So this actually was used in NPM as an attack vector against specifically Azure developers. So anyone using Microsoft Azure? Yeah, so they want you. And if you forgot to namespace your package, so for example, if you're using @Azure/core tracing and you happen to leave off @Azure, guess what? They got you, because they published a package without the namespace prefix. If you get this package, it's obviously going to do something malicious on your system. And when we first saw the exploit, there were about 50 packages in the system. Clearly, they figured out why not stop? This is a great thing. They went up to 218 packages. We reported it to NPM. They took down the malicious packages. But it was a clever attack that was attacking the Azure namespace, Azure Tests, Azure Tools, Catalang. And once it got on your system, it will exfiltrate some data from your developer machines. Since we caught the attack early, it looks like it was just designed to be either like a bug bounty or some sort of test, because they were just doing the minimal amount of information to identify that they'd gotten on a developer machine. They weren't actually trying to, for example, steal credit cards or corporate secrets or something really obnoxious. And they were clever in how they posted it, so you would have trouble identifying who posted it, or the fact that it was like the same attacker using it, because they create a bunch of random accounts with different user IDs and icons, so that you wouldn't be able to identify this was all coming from the same hacker organization. So a little bit more about the JFrog research team. You can find out more about what we're doing at research.jfrog.com. It posts the latest security vulnerabilities, what we're doing, and it's a great resource to be on the bleeding edge of the latest security exploits. But let's talk about an open source project and how we can fix some of this using, of course, the Avengers, because we all love the Avengers. So one of the activities which we're helping out with is the Open Source Security Foundation, OpenSSF, which is part of the Linux Foundation. And they have published SALSA, which is supply chain levels for software artifacts, which is basically a way of defining the different points in the supply chain where you can potentially be attacked. Some of the ones which we've talked about, like, for example, compromised build platforms, a la SolarWinds, using a bad dependency, a la the dependency injection attacks or different attacks like that. And when you look at this, there's a lot of potential exploits which go beyond just using good code analyzers on your own corporate code. So there's a bunch of different attack vectors into your corporate systems. And what we really need is we need an open source supply chain system that is automated, kind of like Iron Man, right? We want the best technology, the best Stark technology. Trustworthy. I don't know why I picked a Russian spy for this, but Black Widow. Dependable, like our SHIELD friends. And having an open source trusted binary network. So we launched a new open source effort called PYRSIA. You can find it at github.com/PYRSIA. And the goal is to create a distribution system for open source code, which is secure by default. So if you're downloading things from it, you know that it's going to be secure. You know that the bits you get in binary form are exactly what you get if you compiled it yourself. That it's reliable, that you won't get, for example, downtime from PyPy's down again, or before Microsoft bought NPM, it was going down every other day. And also open. I think it's really important that if you're depending upon things which are coming from open source projects, and I'm an open source author of a lot of libraries, the last thing I want is to turn over my libraries to an entity which is going to try to monetize on it, or is going to throttle it, or put a paywall between my open source code I'm writing and the rest of the world. So the way we're approaching this is to build a decentralized package registry. It's kind of the Web 3.0 of package repositories. Using peer-to-peer technologies, we're basing it upon libp2p, which is the same underlying technology behind IPFS. We're doing multi-node verification of source build, so the same libraries will get built on multiple nodes in the cluster, verified against each other, and have a transparency ledger written using blockchain technology so that you have an immutable transaction history of all the different changes which are going into this. And we have a bunch of companies we're collaborating with, including Docker, Deploy Hub, and others, to build out the trusted package registries, which will kind of be the backbone of the system and allow you to get secure binaries. Just a little bit of background of this. So the name PYRSIA comes from the Greek system of communication using torches on mountaintops. Basically, they would have 10 torches. They would light up different torches to indicate which cell in the grid for the Greek alphabet which they were communicating. And I think this is a good analogy to what we need for the software development community, where we have an open, wide area communication network of open source libraries that we can all trust and depend upon. So this relies upon reproducible builds where they're available. So I think this gives you the highest level of certainty that a library is exactly what you're expecting if you can reproduce this. And this is possible for a bunch of ecosystems. Actually, the Android ecosystem is quite ahead on this as well, because they care more about security for mobile devices. For places where there's not easily reproducible builds, some Java libraries, some C and C++ libraries, and a lot of Docker images will have trusted registries, which will build it, will verify it, and they'll be done on compute infrastructure which has been audited. And then also making sure that you can't have the sort of dependency injection attacks or domain name attacks by having verification for namespaces and prefixes for artifacts which are published using the system. So the security war is happening. You can already see that the attackers are there. They're getting excited about all the different vulnerabilities in our libraries and weaknesses in the supply chain. Probably you're seeing this in the news as well. I think working on security issues, this is one where your grandma, your parents, they hear about stuff you're working on, like Log4j in the news for the first time. So now the work you're getting is getting some recognition, but it's also scary. So we need help from everyone to make the situation better and to prove the security of software. So speaking of everyone, I need all of your help now, because in the good spirit and history of Java community, we need the whole community to help us out here. So I'd like everybody who is a community member. So if you're a speaker, if you're an author, if you are somebody who blogs or writes about technology, if you happen to go to a Java community conference like Devnexus. Anyone been to Devnexus? So if any of those are true, join me on stage and let's show the world that we care about community and we're going to improve the state of security. So come on up and we'll do a big audience shot on the stage with this in the background. And the only thing people are going to remember about this conference is how packed the stage was up here. So we're also going to prove to the world that conferences are back. Bruno!
Good to see you, man. Great to see you. So long. Awesome.
Yeah.
Last time I saw you.
Come on front.
Yeah. Okay, thank you.
And still wearing the shoes.
Yeah, sure.
All right, fill in, guys. We have a lot more folks to get on stage, so don't stay at the edges. Come in the center. All right, forward, forward, forward. Very good.
Yeah, why not? I hate being one that kneels. So sitting is so much easier. It is. Yes, yes. I was just
All right, so I think we got a good set of folks on stage. So who's our resident photographer? Who's going to be our? Okay, so we have our photographer in the center by the camera. All right, so everyone, do your best Avengers pose on the count of 3. 3, 2, 1. All right, so here's to the Java community. All right, you good, Jim? All right, thanks everybody. Enjoy Devnexus. Come to the party.